Prove by mathematical induction that the next statement is true. The first step is, as usual, we consider the first possible value of n. Here it's 1, so we write for n equals 1. The left-hand side is sum for r from 1 to 1, r factorial, which is equal to 1 times 1 factorial, which is 1. The right-hand side is 1 plus 1 factorial minus 1, which is 1, as the left-hand side is equal to the right-hand side. True for n equals 1. The next, we write assume true for n equals k, and just copy the initial statement, substituting k for n. So sum r from 1 to k, r factorial is k plus 1 factorial minus 1. The next step, consider n equals k plus 1, and the left hand side becomes sum for r up to k plus 1, r factorial is equal to, and we need show that finally it is equal to k plus 1 plus 1, hence k plus 2 factorial minus 1. And since we have sum up to k is equal to something, and if we want to use it, we can split sum up to k plus 1 into sum up to k plus just one term corresponding to k plus 1. So plus k plus 1, k plus 1 factorial, which is equal to sum up to k is equal to k plus 1 factorial minus 1. So it is equal to k plus 1 factorial minus 1 plus k plus 1, k plus 1 factorial. And if we consider the first and the third terms, we can see that there is a common factor, k plus 1 factorial, and we can factor out it and get k plus 1 factorial is multiplied by 1 plus k plus 1 minus 1, which is equal to k plus 1 factorial multiplied by k plus 2 minus 1, which is equal to k plus 2 factorial minus 1. It looks like 10 factorial multiplied by the next value multiplied by 11, and hence it's just 11 factorial. So hence true for n equals k plus 1. And conclusion, if true for n equals k, true for n equals k plus 1. Since true for n equals 1, true for any n is positive integer. And that's all for this question.